I'm going to go over some congruences and Fermat's little theorem. If I can get my ESO not to collapse on me. Congruences, and then Fermat's little theorem. I'm not going to go in detail into how congruences work at the most basic level, but I will discuss, say, the clock, hours on the clock, 12, 1, 2, 3. This is really mod 12. And so, for instance, if you're on hour 3, then 3 mod 12 is equal to 3. That's really just because 12 divided by 3 is really 0 with a remainder of 3. So what you're putting in here is really just a remainder. Okay? That's like the world's most simplistic way to explain remainders and modular arithmetic. So then there's a concept that's used that's called equivalence class. And the nomenclature, it's really a bracket with a number. So for example, let's just say mod 4. So 0, mod 4 is 0, 1 is 1, 2 is 2, 3 is 3. But then when you get to 4, you're back at 0 again. And so these are the equivalence classes mod 4. Okay. Then you can take these and make these beautiful addition and multiplication tables for the equivalence classes modulo any number. It can be any number. It doesn't have to be prime. And of course, when you add these, like for example, when you add 2 and 2, you get 0. When you add 3 and 3, you get 2, because 6 mod 4 is equal to 2. Then if this table is no longer addition, but it's actually multiplication, then 3 times 3 mod 4 is really 9 mod 4, which is really 1. So now all of a sudden this is 1. And then of course 2 plus 2 is equal to 2 times 2. So that's not such a good example, but maybe like 2 times 3 mod 4 is equal to 2, right here. And that's how you build these tables. But again, I'm only like building up to the concepts for what I'm going to be doing in the self-test problems for modular arithmetic. Now, if you would do an example, let me just do an example. 310 mod 11. Okay, so 310 mod 11, let's just do 3 to the 3, which equals 27. 27 mod 11 is 5. And then now we have 5 to the 3 times 3 is mod 11 is the same as this congruence. So for example, so here we took 3 to the 3 times 3. And then this became 5 squared. But actually, I should have said there's 3 of them. Yeah, there we go. Alright, so now we're down to 5 to the cube, 3 mod 11. 25 mod 11 is 3. So this becomes 3. There's only 2 here, times 5 times 3 mod 11. This is 45 mod 11, which equals 1. Okay? Okay, let's do another one. Okay, I'm still, yeah, okay, there we go. Just adjusting the camera. 7 to the 22 mod 23. So 49 mod 23. And by the way, you can do any power of 7. It's just that 7 squared is greater than 23, and it's a good number to get. You want to get a smaller number. You don't want to get too many large numbers. So even though this is a small number, so it's not a big deal here. So this is really 3 mod 23. And so 7 squared mod 23 is equal to 3 mod 23. That means that 7 squared to the 11 power is equal to 3 to the 11 power mod 23. That's what we really have here. Okay? So let's just take it and do it. So 3 to the 11 mod 23. How about we do 3 to the cube, which equals 27. And 27 mod 23 is 4. Alright, so there's 3 of those in here, but we still have a 3 left over. Mod 23. And we know 4 to the third power is 64. 64 mod 23 is 18. So this all of a sudden becomes 18. And then 18 times 3 is equal to 54 mod 23. Did I do something wrong? Oh, I know. I see what I did wrong. Okay. There was a power of 2 in here. This is wrong. Right. So it's really, and this is, again, for problem solving, it's always easy to miss one of these. And I did miss that. So 18 times 9 is 162. 162 divided by 23. It's not 8, it's really 7, right? Because 140, 21, 161 is equal to 1. So this is equal to 1. Right? So all that I have been doing is using, calculating a couple of examples of Fermat's little theorem. Which is a to the p minus 1 is congruent to 1 mod p. Now, p cannot divide a. What happens if p divides a? So if p divides a, then you can express a as a product of p. If you put it in here, k to the p minus 1, mod p is going to be 0. This will be 0. So it wouldn't work. So the only way that it works is if this condition is satisfied. Now, there are several ways in which these problems are given in exams. One of the ways is they'll say something like 17 to the 315 is congruent to x mod, I want to use one of my favorite prime numbers. Now you'll have to check that it's a prime number, or they'll have to tell you. They should tell you it's a prime number, in which case you can use Fermat's little theorem. Now the key is that this number has to be greater than p minus 1, which here is 78. If it's not, then you cannot use Fermat's little theorem. If I gave you this problem, you're out of luck. You have to do it. You just have to start squaring this or cubing it or something and going forward with the steps that I mentioned before. Okay, so that basically lays out these problems. In the next video, I'm going to do a big one that I already know the answer to, and then it'll be followed by my own self-tests that I do to prepare for my final.